I'll assume that you're familiar with statistical hypothesis tests and how they're applied in VSP. If not, please watch the video SA500 before continuing. If you've already gone through the sampling design process and are ready to test the sample results using the MARSSIM Sign Test, refer to video SA510. The MARSSIM Sign Test is used to determine compliance with the release criterion of a radionuclide when it's not present in background. It tests whether the true median of the site exceeds the derived concentration guidance level, or DCGL. For more information about the appropriate use of this test, refer to the MARSSIM manual at the website displayed below. In this video, I'll discuss how to use VSP to set up the MARSSIM Sign Test sampling design. Go to Sampling Goals, Compare Average to Fixed Threshold. This dialog covers several statistical tests for comparing a true mean or median to a fixed threshold. To use the MARSSIM Sign Test, state that you cannot assume that the data will be normally distributed, and then assume that your data are not symmetrical. This design will apply to the first analyte. For more information about working with multiple analytes, refer to video S400. This portion of the dialog is where we set the null hypothesis. In most cases, you will assume that your site is dirty, that is, the true median concentration of the site is at or above the guidance level, until you can provide enough sample evidence to confidently prove that the site is clean. That is, the true median concentration is below the guidance level. The purpose of the sample design process is to make sure you gather enough samples to prove your site is clean, if it really is clean. If you don't provide enough evidence, you will have to continue to assume your site is dirty. This next section of the design dialog is where we control the type 1, or false rejection error rate, specified as alpha. The confidence is a complement of alpha. I'll say the stakeholders want a minimum of 95% confidence, or a maximum of 5% alpha. The next box is the action level or guidance level for the contaminant in question. I'll say that it was 10 units. This next part of the dialog is where we control the type 2 or false acceptance error. We start by specifying the lower bound of the gray region, or LBGR. Let's say the stakeholders decided 8 units was an acceptable bound. Note that after you enter the lower bound of the gray region, VSP displays the width of the gray region, specified as delta. This is the distance from the action level to the lower bound of the gray region. If you would rather enter delta and have VSP show you the lower bound, select Options, Preferences, Input Delta. As a preference, this setting will stay with VSP for all your projects. The next entry is the type 2 error rate, specified as beta. I'll say the stakeholders want a maximum of 10% beta. The final piece of information we need is an estimate of how variable you expect the sample data to be. I'll say we have sample data from a similar site, and it shows a standard deviation of 3 units. At this point, VSP is able to compute that you'll need to take 42 samples in order to meet all the objectives that we set. The MQO button is useful if you have detailed standard deviation information about both the sampling variability and the analytical variability. Pressing the MQO button allows you to split the two types of variability and perform multiple analyses per sample. Press Apply or OK to apply this sample design to your project. If you have sample areas on your map, samples will be placed in them.